Hi everyone, today we're going to be doing lesson 4 of Unit E. We're going to be finding the point of intersection. Question number 1 asks us to determine the point of intersection between the lines y equals negative 2 over 5x plus 4 and line number 2, y equals x minus 3. We'll have to graph each of these lines. Let's graph line number 1 with red. We will start at the y-intercept of plus 4, and then from there we'll count the slope. It has a rise of negative 2, so we'll fall 2 spaces, and then we'll run 5. Then we can repeat this count. We can go down 2 and over 5 again. There's some additional room on this graph that we can backtrack so that we can plot a few more points. Then let's plot our second line, y equals x minus 3. We'll begin at the y-intercept of negative 3, and from there we'll count the slope. There's no slope specified here, but we know that when there's an x, out in front of it is a 1. So this will be 1 over 1 for our slope. So from our negative 3 y-intercept, we'll go up 1 and over 1, and we'll repeat that count as many times as we can until we run out of space on our grid. We can also backtrack a little bit with that slope and plot some more points. We can see that the point where the two lines cross is at 5, 2. So this is our point of intersection. Question number 2 asks us to verify the solution that we found for question number 1 to see if it satisfies both equations. So this means we're going to have to sub in our point, our x and our y values of 5 and 2 into our equations. Let's begin with line 1. We know that y is going to be equal to 2, and we're wondering, is that going to be equal to negative 2 over 5 multiplied by x, or 5 in this case, plus 4? If we simplify negative 2 over 5 times 5, that's like 5 over 1. So we're going to have negative 10 over 5 plus 4. Then we'll simplify the negative 10 over 5 to be negative 2 plus 4. This, of course, is 2, so we've now verified that our left side and our right side of this equation are equal, and that means that 5, 2 is on the first line. For it to be the point of intersection, it'll have to satisfy the second line as well. We need to find out if 5, 2 is actually on the line y equals x minus 3. So again, we'll substitute the values, the x and the y, into our equation. We'll put the 2 in for y, and we'll wonder, is that equal to x minus 3? X being 5, 5 take away 3 is in fact 2. So again, our left side and our right side are equal, and this means that the point 5, 2 is on the line y equals x minus 3. So this means that the point is on both of the lines, and the only way for this to happen is if it's the point of intersection. Question number 3 asks us to find an equation that would intersect with the equation y equals 2x minus 5 at the point 4, 3. Let's begin by plotting the line that we're given. We'll start at negative 5, and we'll go up 2 and over 1 and repeat this count over and over again until we run out of space on our grid. Then let's plot the point 4, 3. We can see that this point is already on the first line. We'll just need to invent a second line that goes through this point. Now, answers may vary to this question because there's not a specific equation that we're required to find. So we can really pick any y-intercept and any slope as long as it's going to go through the point 4, 3. Let's pick a y-intercept of 4. And from there, let's go down 1 and over 4. This will plot us onto the point 4, 3. We can repeat our slope count of negative 1 over 4 till we run out of grid space. And then we can say that our equation of this line is going to be y equals negative 1/4, because that's the slope, x, plus 4, because that's the y-intercept. And this line would intersect with the line we were given at the point 4, 3, as shown on the graph. Question number 4 asks us how we can determine if a pair of lines will intersect by looking at their equations. The only time that lines would not intersect is if they happen to be parallel. And we know that parallel lines are going to have the same steepness or the same slope. So if we look at a pair of equations for lines and we see that they have the same slope, then we know that those lines will not intersect. But in all other cases, the lines are going to intersect somewhere. Question number 5 asks us if the point -2, -1 is the point of intersection for these lines. Let's check if the point satisfies the lines. Let's begin with line number 1. If we sub the -2 in for the x and the -1 in for the y, we'll see that we wind up with -1 and questioning if it's equal to 4 plus 5, because -2 times -2 is +4. And since -1 is not equal to 9, we know that the point -2, -1 is not on the first line. And since it's not on the first line, this means that it cannot be the point of intersection. We can double check this on a graph by plotting both lines. We can start with line 1 starting at 5 for the y-intercept and then counting down 2 over 1 repeatedly. And then beginning with the second line, we'll plot at +2 for our y-intercept and then count up 3 over 2. We can see that the point -2, -1 is on the second line, but since it's not also on the first line, it is not the point of intersection. We can see that the point of intersection occurs somewhere else on this graph. Good luck with your work finding the point of intersection by graphing.